Our mission at Scaled Inference is to enable people to apply AI to build better software and to drive growth in their software products and businesses. And I'm the founder and CEO, and my name is Olcan. I have been a developer for over 25 years now, and I've been into AI for over 15. So I'm really excited to be here speaking to developers especially. Now, I'd like to start by actually going over a very simple example because it's often quite vague what I mean by autonomous optimization. So people, especially developers, find it helpful to go over a concrete example. We call this the hello world of self-optimizing software, and you can actually find it on our website under the developers section. This is just a screenshot of that. Just like any hello world, this web app, all it does is display hello world in the browser. It's a web app. And the only difference from any other hello world is that it can behave differently in different contexts or for different users with the goal of optimizing its own metrics, which we define. Now let's break that down a bit. There are three key pieces to any self-optimizing software application. There's the context, which can be used to take better actions. There's the actions that are being taken, and there's the outcome which we're optimizing for. To understand how these things interact in this example, in this hello world example, let's actually visualize all the possibilities which can be useful. So first, we observe the context. In this case, this is simply whether the user is a child or an adult, which is determined randomly, which you can think of as a random user coming to our website or opening our app. Second, we make a decision that will affect the behavior of our software. In this case, simply the style of the hello world text. The first action here is called the default action, which is really the default behavior of our app until we start optimizing. And you can see the labels I put under the different styles of hello world. They're called regular, fun, and classic. Third, we have an outcome that we observe. In this case, whether the user is happy or not. But of course, this represents any key event that we want to optimize for. It could be the user signing up on our website, completing some onboarding flow on our app, responding to some notification, completing a checkout process, and so on. Now, of course, different users behave differently, which is the whole point. So let's see what that might look like. Now, in this example, we assume that the different types of users respond differently to different styles of hello world. So let's see what are the assumptions that we're making. So in this example, we assume the displayed happiness rates for different types of users and different kinds of actions. Now we see that for children, the fun style, the bright green hello world is optimal with 54% happiness rate. And for adult user type, the classic style is optimal with 90% happiness rate. So if we were able to take the right action in each context, then we could achieve an average happiness rate of about 72%, assuming that our users are half adult and half children. Now, in contrast, if we always take the default action, then we're going to get 30% happiness rate for children and 50% happiness rate for adults, for an overall happiness rate of about 40%. So the idea is that if we could take the right action in each context, then we could improve our happiness rate by 72% in this example. Now, if we wanted to do this manually, of course, we could write a conditional statement just like this one. The problem then, of course, is that we probably do not even know where to begin because we wouldn't know which context variables to condition on. We don't know what's relevant. And even if we knew, we wouldn't know which action to take in each context. And imagine we somehow figure all that out, maybe we get lucky, but what happens as things change in the future, right? Is this policy or conditional statement going to be valid a month from now or 2 months from now when we change our app again, or when our users change, or anything else changes? So how would we even maintain this over time, right? That's one of the significant challenges. So much easier would be if we could simply ask an optimization platform to decide the right action for us. This platform could do the hard work of learning and implementing whatever the optimal conditional behavior is. And it could maintain that over time. So, of course, this is exactly what we do in the Hello World example when we determine the action in the middle part. So let's just put it back together and zoom out again. Now, to make it even more concrete, I'd like to actually do a live demo for you guys where we optimize this Hello World app from scratch using our platform. So this is our website, the developers section. If you scroll down here, you can see the Hello World example, as I mentioned, on our website. So this is the web app that I described embedded on our website. And if you actually run it on our website, you will get mostly optimized behavior. So if you hit rerun, you should have it mostly do the right thing. So in this case, context was adult, and the action that was chosen was indeed classic, which we know is optimal. Again, same thing. Here, same thing, but the user was happy. Here, child was the context, and hello world, the fun variant was chosen, and the user was happy, and so on. And you can take a look at the code, the CSS, the HTML, and the JavaScript. It's all public, and you can actually edit this in the code pen and see what your edits do. So feel free to play around if you like. Now, I have the same application on the right side of my screen. You see the code on the upper right. It's a little squished here, but you can kind of see that it's the same code. There's also the CSS and the HTML if you want to take a look at that. On the bottom right here, you see the same web app, essentially. The only difference is this one has a few more features that I'm going to need for the demo. So let's actually go to our AMP console under an account that we created specifically for this demo. I'm going to log in here. And this is a clean account right now, so we're going to create a new project. Let's call this Demo Dev Week NYC. I'm going to resize this a bit. Great. So the first thing to do is to copy the project key into our app, which makes it really convenient with this text box here. Once I copy the key, each time I run my app, it's sending what we call a session to our platform. So it's observing these events and making these decisions as I described. Now, you might notice that the Hello World style is not changing here. It's always the regular style. That's because we haven't enabled optimization yet. In fact, we haven't even defined our metric yet, so we're going to do all that now. Let's actually define the metric now. Let's call it happiness. We define that as occurrences of the user happy event, and we want to maximize that. There you go. So that's our metric. We see we already received in our backend about 17 sessions. We can actually take a look at these sessions. Let's dig into this one. There's an AMP session event with a whole bunch of properties attached to it about my browser, my operating system, time of day, and so on. There's the user type, which is adult in this case. There's a text style, which is regular, and the user was happy in this session. And here's another session where the user type was child, the text style was regular, and the user was not happy, meaning there was no user happy event. So the integration seems to be working. All the sessions and events look like we would expect. So let's actually go in and enable optimization. To do this, we just go into settings, we go under decisions. We see that the platform has detected already the decision point, we call it, called text style. You can see this in the code where it says amp.decide on the upper right. I'm highlighting it right now. And if we look at the variations or candidates, we call them, at this decision point, we can confirm they make sense. It's regular, fun, and classic. So we can now approve this decision point to be optimized and save that. Next, we're just going to allocate some percentage of sessions to be optimized. We call these amped sessions. And in this case, I'm allocating 80% to be amped or optimized. And that's pretty much it. So at this point, what I can do is basically hit this Run Mini button and have the web app continuously run sessions. So here you can see that the text immediately starts varying, which is what you expect when you enable optimization. And after about 30, well, one thing I do here is show you guys that we have intercom. So if you have any questions about anything like what just happened in the demo, you can go ahead and ask us, and we'll have someone respond to you very quickly. Right, so in this case, the demo is working as expected, and you can see the metric beginning to improve after about 30 seconds or so. And here we dig into the rules or the policy to see what is the optimal policy that the system has learned and deployed. So in this case, we confirm that for adults, it does classic, and for children, it does fun. And at this point, the metric is up about 40% overall, and about 40% in each context, which you can see at the bottom here. So you can see that 2 segments were automatically discovered. The platform does not know about these starting out, and the performance is improved in each of those. One thing you can do, even without decision points, is to look at how each segment is performing with respect to average. So in this case, our platform has detected that children are doing about 26% below average compared to adults. So this kind of information can be useful just to get started, even if you don't have your decisions or actions integrated yet. The other thing you can do is hover on the charts to get a sense of what's happening at each time point, and to get a history of the project. So you can see that we changed the allocation of the project from 0 to 80. That's recorded. We approved the decision point, and then we created the metric. And all these things are a part of the project history. Now, it's always a challenge to go from a hello world example to a real world software application, as you all know, right? We have something sort of in between. We call this the amped store. In this case, the only difference is that the context and the action and the outcome are specific to the e-commerce domain. So in the context, we might have whether the user is on a slow connection or a fast connection, which actually significantly impacts user behavior in e-commerce, which some of you might know. And for the actions, we have things like the call to action color, how many steps there are in the checkout process, and whether we offer rush shipping or not. Again, these could be any variations that we want to explore. And the outcome is typically whether there's a sale conversion or what the revenue is on that sale. Now, I'm not going to go into detail on this intermediate example, but I just want to point out that we have actually fully implemented this example store in all the major platforms, including iOS and Android. And also that all of this is actually open source at that URL that should be visible on the screen. Under our GitHub account, you should be able to find it. So you can go ahead and clone it and play with it today if you like. Now, let's review a couple of real-world examples. I want to start with a mobile app called the Simple Habit Tracker. In this mobile app, like many other mobile apps, there are 3 tabs. The first tab is called Ideas. This is where you select your habits that you would like to do each day. The second is called doing, which is where you report on your activity, like the fact that you exercised that day or not. Finally, the third tab is called done, and this is where you review your historical progress and results. What most developers would do in this case is to just open the Ideas tab by default, no matter what. And this would be simply the easiest thing to do, and you would say that this just works in most cases, so why do anything more complicated? But what if we just let the platform determine which tab to show in order to optimize for some metric? In fact, we did that, and the metric we chose is simply to reduce the tab switching, which we call a tab decline. So once you open the app, if you quickly switch the tab, we consider that a negative event, and we try to minimize that. And we were actually able to minimize that by over 80% in just a couple of weeks. And you can imagine that an 80% reduction in this kind of user experience friction is quite significant, and shows that it's possible to get significant improvements with little effort. And to make that more concrete, let me show you what a session might look like. Here's a particular session. Key here is the decision point, which is the selection of the tab, and the code for that in Swift, I believe, is at the bottom. So there's a single line where you determine the tab. And if you look at the optimal policy here, we see that the platform has learned to condition on one of the properties attached to an earlier event, which happens to be this event called context deep for some reason. What the platform is doing here is essentially that if no idea has been chosen yet on the Ideas tab, then the user should be sent to the Ideas tab. That's tab 0, first tab. And otherwise, if the user has already chosen at least one idea, then the user should be sent to the second tab. So this behavior, this conditional behavior that minimizes the metric, was learned automatically. Now, let's look at an e-commerce website example. In this case, Teespring. Teespring is a major platform for buyers and sellers of custom apparel. They do over 100 million a year in gross merchandise volume. Here's the code that they added to their product pages. You can see it's not much code. And here's just a couple of the variations that were explored. Here, one of the variants encourages adding things to cart, with the big green button. The other variant encourages the user or customer going directly to checkout. And you can imagine that if the customer is likely to be impatient in a given session, then it would make sense to send them directly to checkout or encourage them to go to checkout, because it's more likely that you're going to generate revenue. But you wouldn't want to do that for everyone, because then your average cart size is going to suffer likely. So what you'd like to do is to conditionally be able to apply the right variation, which is what our platform can do. This is an example session again in this case. And here's the result in this case, which is a significant improvement in sale conversion and revenue, which is very impressive for that amount of work done on the website. Now, in this table, we summarize a sample of use cases that we've explored and the ROI results that we've delivered. This is actually representative of what people can expect under this paradigm. It's not a selection of the best use cases or anything like that. And in fact, these results are only within the first couple of months or couple of iterations with the platform, and should get better as companies and developers adopt the platform on a longer term basis. Now, note that the ROI is generally quite high here, but does depend on the scale as well as the baseline value of each session. And the reason for this is autonomous optimization actually creates value by boosting existing value. So it's important that you're able to apply it to sessions that are already valuable to you. In this table, we can take a look at how the two variables, the scale or number of sessions per month that are optimized, and the value, the baseline value per session, how these two parameters affect ROI, you can see that if you could generate 10 billion sessions a month with $100 per session value, you would have a dramatic ROI. That's on the upper right. That's probably not realistic. And on the bottom left, you have very few sessions with very little value per session, which is where you might actually get negative ROI from a platform like this. So most of the use cases we've explored fall in the middle band that, as you've seen. Now, let's take a step back and kind of review how the platform works at a high level and kind of compare with other methods that you guys might be familiar with. The first thing I like to point out is the inner loop. This is what we call the self-optimization or autonomous optimization. This is the part that's fully automated that we hopefully don't have to worry about. It's reliable. It learns and maintains optimal behavior and metrics. And we generally don't have to think about it much. Second, we have the outer loop, which is what we do as developers, basically to iterate on existing use cases and to develop new use cases. This outer loop is actually critical to drive further growth, further continued sustained growth. So it's not sufficient to simply have autonomous optimization as the inner loop, although that does make it a lot simpler to make progress. Now, here in this chart, I just look at very, very high level how autonomous optimization would compare to other methods in terms of effectiveness in improving your metrics, and in terms of, on the horizontal, the applicability to the key metrics you care about, things like user engagement or retention or revenue or those kinds of metrics. Now, machine learning, or I should say custom machine learning or AI, would be on the left side of this. It would be very effective, or it can be very effective, but it would be very hard to apply to the metrics that you actually care about. You would generally apply machine learning or custom machine learning to a small sub-problem that's hopefully relevant to what you care about, but not quite what you care about. And on the bottom, we have analytics and A/B testing, which are very easy to apply to the metrics that we care about, but are just not effective at improving them is the problem. So autonomous optimization kind of delivers best of both worlds. Now, in comparing to custom AI, I'd like to just point out the technical debt issue, mainly in deploying and maintaining such systems in production. It's very important that developers and companies make absolutely sure that they know exactly what they want out of this in terms of the key metrics, especially. Google has published quite a few papers on the technical debt and related issues, and I have just 2 of these papers on the screen if you guys would like to read more. The code at the bottom that says machine learning has become alchemy is from a famous researcher, Ali Rahimi, in a recent conference, and mostly referring to recently popular ideas such as deep learning, which are actually even more difficult to deploy and maintain in production. Now, in comparing to A/B testing, which was the horizontal axis, if you guys remember, we can actually present head-to-head results on real-world A/B tests that we had access to from some of the most sophisticated companies. And in every case that we've had access to, we find that autonomous optimization can drive metric improvements and value gains, as I described earlier, much faster than A/B testing, often almost an order of magnitude faster, even if you discount the human delays in the process. So even if you remove all the human delays, you can generally improve your metrics much faster, much more robustly using autonomous optimization. Now, what are the reasons for this? There are actually quite a few reasons why we might call this testing-based optimization, why testing-based optimization doesn't perform quite as well as we would like. The first one, probably the biggest reason, is that changes over time invalidate past results. I mentioned this at the beginning. Even if you knew what optimal behavior was today, you ran all your tests, all your tests concluded beautifully today, and you deployed that, how do you know that's still valid a month from now? Are you going to just keep repeating the same test over and over? And the answer is probably no. So this is a big issue. I'll give an example of this in a minute. Next, even if that wasn't an issue, it turns out that optimizing based on testing, based on statistical significance, is actually quite slow to begin with. And one of the main reasons is that you typically control for the risk of a false positive, which is the risk of deploying a variant in production that actually does not have the improvement that you think it does. But it does not balance this with the risk of not deploying a variant that actually does have an improvement. So in general, this process does not account for the cost of inaction, which hurts us and slows down the whole process. And combined with the fact that things are changing over time, you can see how this kind of process is not going to yield optimal or sustainable results over time. And a lot of you who've done A/B testing probably know what I'm talking about. And the third thing to point out is that A/B tests are actually, because they measure averages, are completely oblivious to what we call contextual wins and contextual losses. So even if you conclude on average that a variant B is much better than a variant A, there's usually a significant subpopulation or subsegment, let's say 30, 40, 50%, where the reverse is true. So A was actually much better than B, but that was completely lost in the averages that you calculated. So we call these contextual wins and losses, and these are things that actually a system, an optimization system, can take advantage of to personalize and contextualize your application. And these are also things that you should look into to better understand how your users behave on your applications or how your application behaves. Here's a concrete example for changes in validating past test results. On the upper chart, you see, and it's a little small, I apologize, but you see 7 or 8 actions, the performance of 8 actions plotted over time. It's about a time period of about 2 months. On the left side, which is the month of April, if you ran an A/B test, you would conclude with near 100% significance that one of the actions, I believe the orange action, is by far the best action. But in the following month, the month of May, the orange action is actually only the 3rd or 4th best. So things have changed quite significantly in the course of a month. And if you ran a test and concluded that test, you actually wasted your time. And you probably suffered in terms of reduced performance during that month. So clearly, what you'd like to do instead is to maintain continuous monitoring and continuous deployment of the best known policy at any given time, which is what an autonomous optimization platform can do for you. The other thing to note is on the bottom chart, we actually plot the actions with a unique color per action that are actually being utilized by the platform. So it tells you, how many actions in a given time, so in a given slice, how many actions are actually being utilized. And you can see towards the right side, for example, that only a couple of actions are being utilized by the platform. This is actually extremely typical. So even if you make a whole bunch of variants, a whole bunch of actions available to an optimization platform, it'll typically only use a small fraction of those, only a few of those typically. What this means is that you can actually iterate on your code to remove the actions that are not being used and keep your code clean and easy to maintain. You can think of this kind of like A/B testing, except that it's much more powerful because multiple actions can be utilized and they can be applied contextually, right? Not only that, but during all this process, the system is actually continuously optimizing your metrics. So you're not really running a test here. You're running an optimization process and just periodically revisiting the process to see if you can actually simplify it. And this is another example in this case with 18 actions, where an A/B test would really not reach any significance even after months of testing. In contrast, if you apply autonomous optimization, actually in this case, we're able to drive revenue gains of over 10% throughout the whole time. So all that time that you would have wasted running an A/B test and probably hurting your revenue, you could be gaining 10% of revenue. And at the end of that process, you can actually get a decent sense of which actions are working. In this case, if you look at the right side of the chart, and ignoring blue because I believe that's the default action, you see that purple and brown actions are dominating on the right side. So we could go ahead and remove almost all of the 18 actions and only keep the couple of actions, the purple and the brown, if we wanted. Now, before I finish up, I'm going to take a step back and another step back, I would say, and kind of look at the even bigger picture. And I think that it's very important when we talk about optimization and these different paradigms to really think about what we're really after as we apply these things. And ultimately, at the end of the day, I would say that it turns out to be about growth in some kind of software business, and growth at various levels of the business. So a lot of the times by growth, people mean user acquisition, but actually growth should really be thought of as an end-to-end measure, all the way from user acquisition to lifetime value. And if you look at it that way, then you can say that this is what manual optimization looks like today. It kind of expands our funnel a little bit at each level and gives us a stronger business overall, but perhaps only marginally so. And we get this again from essentially manually applying analytics and A/B testing and maybe custom machine learning or AI. But in contrast, as we reviewed today, this is what autonomous optimization could look like, which is a much more significant improvement at every level of the funnel, and ultimately at the bottom, a much more significant impact to the business. And this is what reaching your ultimate potential looks like, of course. And yeah, that's all I have. Thanks everyone for listening. And please don't forget to get a free account. We actually opened the platform up just about a week ago, so anyone can go and create an account. And you could actually start optimizing today. Thanks.